All right, so let me give you examples from Algebra 2 of functions. Yeah? I'm hoping this idea is a reasonable one. F of x is x squared. You guys all remember this one? Know and love this guy, right? So if I made a table of inputs and their associated outputs, okay, those of you who have had me know what my 5 favorite numbers are. Perfect. Why are those my favorite numbers?
Easy.
Because they're small and round and easy to put into things, right? So where does -2 go when I put it in the function f of x is x squared?
4.
4. Where does -1 go?
1.
1. Where does 0 go?
0.
0. Where does 1 go?
1.
1. And 2 goes to?
4.
4. Perfect. So please note, kind of embedded in this picture, right, this table that I've drawn, is this kind of arrow diagram, right? Now, does this one have a problem because 2 things go to 4? Does that mean it's not a function?
No.
No, this one's allowed to be a function, right? Okay, I got to recall some other stuff. So let me recall quick. You guys know how to graph this?
Yeah. Exponential curve.
What does this thing look like? This thing looks like a parabola. Good. Okay, it passes through, what's that point?
0,
0,
0.
0. How about over here, I should have a point that obviously is not to scale.
1, 1.
Should be 1, 1. And then up here, there should be another guy. Again, obviously not to scale.
2, 4.
2, 4. Cool with this? There should be 2 more, right? These guys? I'm going to assume you can label those. What's the important thing to remember about graphing a function? Seriously? What do the pairs look like? Good, they're x comma f of x pairs, right? They're an input-output pair. See that? That's the set of points I've marked to draw that parabola. Is all cool with that? It's very, very important that input-output pair idea be in your head with the word graph. Cool? That's new. Don't worry, we're going to come back to it a bajillion times. Cool? So what are the points on a graph?
X and f of x.
X, f of x, or input-output pairs. Cool? All right. Where's this business happening? Like, I think I should be able to see that someplace on that picture.
Same way.
Let's all see that? That's here, right? That's this line going across. You guys have a thing you remember about lines like that?
Yeah, it's not a function if there's a vertical line that can pass through 2 points.
Good. So a set of points in the plane, right? If I draw some rando squiggle, is a graph of a function if any vertical line only passes through once, right? So what's the thing about horizontal lines, which I've got here? Okay, let's.
Yeah, it's not.
Let me leave a space here.
It can't be an inverse function.
Horizontal line thingy. Test. Right? That tests for something. I'm going to fill that in a second. Right now, I want to go. All right. You guys maybe have forgotten the horizontal line test. That's fine. No worries. It's been a long summer.
Does
Totally
it tell
understand.
the degree of the function?
Dude, so cool. Yes, kind of. We'll talk about that later. You and I, none of the rest of us. All right. So what I want to think about is I want to look at that thing and I want to think unsquared. Could I unsquare? You guys see that? Like if I took this table and I thought to myself, okay, there's numbers like 4 and 1 and 0 and 9 and 16. Can I unsquare those?
Kind of. Almost all of them.
Yeah.
Okay, how about what's the unsquare of 4?
2.
2? You guys all buying into that?
-2 would be.
Oh,
Plus
shit.
or minus.
Plus or minus.
Right? Really, there should be like this, right?
Plus or minus 2.
You guys see that? What's the problem with there should be like this?
Because you're
It's not a
square
function.
rooting it and you square it down.
Yeah, I tried to draw this table, right? You guys see that? But really, I maybe shouldn't have been drawing the table. I should have been drawing one of these arrow diagrams. And 4 should really honestly go to both places, right? What does that tell you?
It's not a function.
Yeah, this thing's not a function. Unsquaring is not a function. Okay, so where was that it's not a function thing over here?
One normal output.
There was an input, right?
Uh-huh.
2 and -2, a pair of inputs, that gave me what? They gave me the same output. So if I try to go backwards, right? If I try to this rule, you guys remember what the actual, nice. I'm trying to invert this rule, right? I'm trying to create an inverse function. But there isn't one. And there isn't an inverse function because when I flip it over, right, I'm running into this problem.
Because the x's and the y's change places.
Yeah, because when I want to do an inverse function, I need to exchange that outputs for the inputs, right? And here I had collapsing, right? Those two went to the same place. So when I flip this thing over, I get exploding, and I'm not allowed to do exploding. You guys see that?
So is that what the horizontal line test is for?
Yeah, perfect.
To check and see if there is an inverse function?
Exactly. So the horizontal line test is a check for inverse function. And really what it is you're running the vertical line test on the picture after you flipped it over. You guys see that? Okay, this is a lot of stuff probably, right? So the idea I want you to remember is that there were some ideas, there were some things we did in Algebra 2, like square rooting, that we were trying to think about as functions that maybe weren't. Right? Unsquaring isn't a function. The square root function is a compromise. You guys remember what the picture of the square root function looks like? Very good.
It's like a shooting star, but for
Looks like this, right? Looks like half a parabola. Where's the other half of that parabola?
going down.
Down here, but why did I take it off of the picture? Yeah, because it would fail the vertical line test. I want that square rooting idea to be a function. You guys cool with that? So this is maybe g of x is square root of x. Cool? Question thing? These two, g and f, are not inverse functions. You guys see that? They're only partially. This one undoes f, but it only gives you the positive inputs that work for f. You see that? Cool?